Okay, ladies and gentlemen, good morning and welcome to our EUKI Academy web seminar Learning to Estimate Your Emission Reductions. I'm Julia von Fiebern, the EUKI Academy coordinator, and it's my pleasure to welcome you today to this important topic. We know that you are currently preparing your project outlines, which we are looking forward to receiving soon. And as you might be aware, the EUKI application form also asks for your project's contribution to greenhouse gas emission reductions. And of course, we recognize that this may be difficult for organizations who do not usually deal with this matter, or also for projects which may not directly reduce greenhouse gas emissions. And therefore, the aim of today's web seminar is really to provide you with a theoretical foundation. We will share some general information and also methodological approaches to estimating direct or indirect emission reductions. And however, we are fully aware that these may be more relevant or applicable to some projects than to others. So when you are preparing your project ideas, we would like you to keep in mind that in this first stage of the application, we do, of course, not expect a fully developed emission reduction concept. However, we do expect you to consider the impacts and effects of your project and demonstrate to us that you have done so. So the techniques or data sources shared with you today may be helpful for you in this process. And if you have any questions or comments throughout the event, we kindly ask you to write them in the chat, and we will then collect your questions for the Q&A session at the end. However, we expect a high number of participants, so if we don't get through the questions, we would collect them afterwards and respond to them in an FAQ document, which will then be circulated together with the presentation and the recording. So also, for example, if your questions get too detailed to your specific case or something, you can also send us an email to info@euki.de. However, please bear in mind that we cannot, of course, offer you like real individual counseling. But with that being said, thank you once again to all of you for coming, and I will now hand over to Stefan Wehner, who is a founding member and senior advisor at the Greenwerk. And Stefan, the floor is yours.
Thanks a lot, Julia. Very good morning to everyone. My name is Stefan Wehner. As you said, I'm advisor on carbon market projects, on climate change mitigation projects since now 15 years, and work in the field of estimating climate impacts, in particular from developing projects since about a decade from now, working with institutions like the German Technical Cooperation, UN bodies like UNEP, UNDP, but also institutions like the International Climate Initiative, and nowadays also with the European Climate Initiative on supporting projects like yours in estimating the outcome and outcome related to greenhouse gas emission impacts. The agenda of today, I would like to briefly, in about 40 minutes, give you an overview of common approaches, a good understanding of climate impacts of the identification, and some methodological approaches that can be applied, and also try to give you a few examples. We try to keep as much as possible with regards of the time towards Q&As in the end, but as Julia said, please feel free to put any question in the chat. We will collect them and try to answer them afterwards as far as possible. So after a short introduction, I will give you an overview of the general possible climate impacts related to your projects, then the methodologies that are out there, and to relieve you already maybe in the beginning, you're not the first project that is doing such a task and have to do such a task of estimating emission reductions from your activities. There are a lot of material, resources, and tools and methodologies out there, and I hope I can show you a little bit on how to approach them. And then, as I said, finally, a short example. So, as we have heard from Julia, there is an expectation that obviously an EUKI project should provide an estimation of GHG emission reduction when proposing the project, but also during the implementation. And we distinguish in the long term between directly reduced and indirectly reduced emission reduction, which are defined in the standard indicators. Directly means, and we will look at this in a second, that it's under your control. For example, directly financed, any measure that is directly financed by your project. Indirectly, it's rather you are helping partners, you're enabling future emission reductions or emission reductions by others that then only can indirectly relate it to your projects. We will attribute it to your project. We will look in this into more detail. Just to highlight again, right now at the idea stage, it's important to demonstrate that you have a kind of contribution and also foresee a contribution in future. But in the, for full projects later, ideally these are also quantified and underlined with some assumptions if you don't have direct data, but at least a plausible estimation and a clear explanation of your mitigation potential that you foresee for the future or what you have achieved during your project implementation. And the key here is always to be transparent, provide a traceable calculation, but also be conservative as possible. So there's a clear expectation. On the one hand, the question is how we don't do that. And I would like to start, since we have a lot of participants here, I would like to start with a short survey and poll and invite you to answer the following question using the Menti, either the code that you find up there on menti.com, entering the code that you see on the screen, or scan the QR code to the right and provide the answer to the following question. Have you already identified and even quantified emission reduction or carbon stock enhancements for your project? The answers, as you can see, is yes, we have a solid estimation. Yes, but we face some challenges and are uncertain about the results. No, we would, but we would like to learn about the possible approaches. And no, we have not yet thought about it at all. So I see coming in the answers. I hope you can see it live here as well in the screen. It's already quite a tendency towards the third answer, which means you don't have a emission reduction quantification yet, but would like to learn about it more, possible approaches. Which is a good sign, because then you are correct in this webinar, because that is exactly the purpose. What we also see, we have one solid estimation already in place, which is great. So maybe later in the Q&A we can learn about this as well. So the majority, I think, would like to learn more. We have also a few projects that have already done the first estimation, but still have some challenges and some uncertainties. So maybe also today or in the next steps, we can help you to overcome these challenges and be more prepared to finalize the estimation. And then we have a few not even started yet, but hopefully with the information today, you will be able to start. So yeah, thanks a lot for sharing this view and your status where we stand, which gives us a good idea. And hopefully, we can now give you a bit of insights on how to do the estimation. First of all, I would say I would like to simplify the overall process. Typically, it's a challenge to identify how to start with the estimation. And from my experience, I think there are three key questions, three key steps in estimating mitigation potentials from projects, from activities. But there are also some challenges and pitfalls, maybe, and it would be good to be aware of that. The three main points, main steps are for any project or activity, be it an EUKI, be it another project, to do a first analysis of your impact. So understand what you are doing, or understand your project activities that you are undertaking, but also what they might have and what kind of impact they might have beyond your project boundary, beyond your control. So understand the ultimate effects out of your projects, and for that, typically a good start is to really take your logistical framework, take your result metrics, whatever you have in mind, take your activities and think of what would be the implication, what would be the impact beyond your project. And by doing so, a good tool is a causal chain to draw really down what would happen with, for example, the knowledge that partners gain through your project. What would happen with the policy that you are supporting? What would happen with the pilot project that you are undertaking? So this kind of clear understanding will help you to identify impacts, identify the underlying technologies that also would lead to a change in energy, a change in energy demand, energy supply, and ultimately in reduced emissions or reduced enhanced emission reduction. Obviously, the other way around as well, we could also identify rising emission, but we're aiming obviously for reducing emissions. So it's important, but also a challenge to identify these impacts and to distinguish in particular between what we can directly influence and what is indirectly influenced by our project and would result into mitigation mitigation in the end. We will look into a few examples on how that can be done. But this is basically the first step is, I think fundamental to identify potential mitigation activities, actions that are related to your projects. And often it's underestimated how important this first step is. Because the second step then relates to the identified activities in your project scope or beyond that scope that you are just influencing with your activities. Because once you have identified the technologies, the changes in behavior, for example, then you can select and apply a suitable mitigation estimation methodology. And these are available out there. A lot of approaches are there, as I said, that can be applied, but you need to understand, is it applicable or not? The methodologies will help you to identify the emissions sources that you need to look at, to define a baseline and the project scenario. We come to that in a second, and how to then to quantify and estimate your emission reduction. Challenge here often is how to find the right methodology, and then some of them might be quite complex and cumbersome, how to apply it to your situation, because typically it's not needed necessary to apply them to a full extent, but follow the general approach there, because we are doing an estimation here, we are doing an educated guess in most cases, and we are not asking for certified emission reductions, for example, which would relate to some of the methodologies that are out there. The final step, which is in particular important during the implementation, is to have a good understanding of which data you need for the monitoring, which data you need for the estimation ex ante in the beginning, but also then ex post during the implementation of your project to verify your emission reduction. So a good understanding in the beginning of which data is available, which data do we need, which data can we source as a default value from some statistics, or which data do we need from our projects, from our partners, which might be to collect it or even to measure. So that final part is already integrated in the estimation in the beginning. Good overview of data that are required for the quantification, but in particular have also an impact on the reporting later. So today I will in particular focus on 1 and 2 because that is most important now for the estimation in the beginning and give you some hints for the data availability in the end. So understanding climate impacts and mitigation and development projects. As I said, we have to distinguish between direct and indirect GHG impacts. Direct, as it is defined in technical cooperation, is all to any action that is within your project control, can be controlled, steered by you, and that lead to a direct result. In terms of direct result related to emission reduction, obviously anything that is related to activities that cause emissions or reduce emissions and is under control is meant here. You see to the right a graph where we try to illustrate this a little bit along a result chain. So for example, direct impact would be if you invest and provide financial resources to a partner, to a project, and with that resource, a real physical and measurable implementation would take place. For example, the installation of a solar PV plant. Then a direct GHG result would be dedicated, could be dedicated to your project. This typically or often relates to pilot activities and projects. The majority of technical cooperation projects rather work in the area of indirect impacts. So any emission reduction results outside of your project scope, outside of the radius of action that you can only indirectly influence. So in this case, there should be still a kind of relation to your project and an attribution because you might have influenced this, but you are not doing the eventual investments. You are not doing the implementation. It's someone else who is doing it. Your partners, your target groups, that are influenced by capacity development, by policy implementation, by technical assistance. So you see to the right, the outcome here is that you enhance the mitigative capacity, as we call it, or you enable someone to take actions with regards to emission reduction. So we have typically a shorter or a longer causal chain of effects, and in the end, some indirect effects in results and GHG results. But it is, as I said, outside of your direct control. You can just see, okay, something has happened, and you could report on that. So a few examples on how to distinguish between the two. We have here 4 causal strings. In green, you see project activities that projects typically undertake. In lighter green, we see some intermediate effects, and in the end, in blue, some CO2 emission reductions. And we have a dotted red line, which means that is the project border, the project scope and limitation. So anything in dark green is under your control, are your activities, and then after that we have the kind of attribution gap because someone else is taking some actions based on your support. In the first example, number 1, we have the promotion of energy efficiency services. So you are working with service providers on energy efficiency, helping them, for example, setting up business models, train them, and they are active in the market. So the overall improvement of energy services will be enhanced through trainings, but then indirectly, this will influence a greater acceptance of energy efficiency service, a more and higher implementation of energy efficiency measures, and eventually reduce energy consumption through the implemented measures and reduce emission reductions. But it's not done by you. It's done by those service providers that you have worked with. So the attribution can be clearly shown, the relation to your project, but it's indirectly because in the end they do the implementation, not you. The same, or a different case we have in number 2, where we have implementation of pilot projects. For example, your project is performing energy audits in schools or other public buildings. And out of that audits, 10 projects would be implemented with real measures, energy efficiency measures, which are also financed by your project. And you show and demonstrate the feasibility and profitability of that. So directly with under the control of your project with financial resources, these measures are implemented, and the emission reduction can be claimed as direct in this case. If these pilots, though, are upscaled and someone else in other municipalities at the national scales are doing the same based on your activities, and in the end, also this leads to reduced energy consumption through the implementation, but financed by someone else, then we have an indirect impact based on that. So you see the causal chain can extend it here, but towards the indirect part. The third category, often we have trainings, we have general capacity developments. We always need to see how long and short the causal chain is. Can we still relate this or not? But in this case, training of managers and specialists, meaning here in public buildings, managers of the public buildings, they apply their learning afterwards in the companies. They apply energy measures and they reduce reduced energy in the end. So you have the training can clearly relate to some behavioral changes in this case, and that's why you could claim for indirect emission reduction. The final stream here relates to policy and incentive structures. For example, if you're working on enhancing policy frameworks or implementation of them or formulation of them. In this case, the project established a dialogue platform, and in this dialogue, there was agreement on organization for an incentive program, but the project activity stops there. But in the end, this incentive project program was implemented. It leads to implementation of energy efficiency measures and reduced emission reduction. So also here, indirectly emission reduction. So you see 4 different categories, 4 different causal chains that have either a direct or an indirect impact in the end. And that is what I meant is important to understand what is direct, what is indirect. And for your project, really think about your activities, think about your causal chain, and identify these potential mitigation areas. Once we have done this, once we have understood where we have a change in an emission reduction potential, we should think of how we can quantify that. And the general approach, the general calculation is to calculate the emissions related to the what we call a baseline situation or a business as usual scenario, a baseline scenario, where we would have a situation without the project. So that could be typically the continuation of the current situation. And we have a situation after the project implementation, where we have a typically reduced project emissions. There could be still project emission, or they could be zero, depending on the technology. So this comparison or this distinction is the key simple calculation. In some cases, we also need to consider leakage. Leakage emissions means that some of the technologies, for example, that you are replacing might be used elsewhere and still continue to emit. For example, if you replace old ACs in a public building, then that AC, if that is not demolished, then can be used somewhere else and would still continue to consume electricity. And that's why your effect is less. So we need to consider also leakage. To understand the baseline and project scenario, it's important to, as I said, identify the technology, identify the reference cases for each of your activities. And this can be sourced typically out of the methodologies that are out there. They give you hints and approaches on how to identify a typical baseline scenario. As I said, most often the continuation of the current activities and practice is the most suitable one, or you can call it also business as usual. But there are also other cases where you refer to a certain technology that at the moment is the most attractive, most economically attractive technology in place, or we can use an approach that it's called benchmark. So looking at what typical circumstances in the last years, which technologies would be prepared there in that case, or used in that case, sorry. So we need a reference case where we compare our new project situation to our project scenario, and then identify the difference between the baseline and project scenario. The project scenario, as I said, is the new situation after project implementation, and we need to identify if there are still emissions or not in your project. For example, if you have a project related to waste project, there might be still some emissions after your project implementation due to collection of waste and then composting, for example. But if you have renewable energy projects, then in many cases, the project scenario or the emissions under the project are zero. Key question often is how to identify a suitable methodology then to your project and where to get guidance for the quantification. There are a few standards out there that offer a first start to look at suitable approaches. Very prominent and large mechanism is the Clean Developer Mechanism under the UNFCCC, under the United Nations Framework on Climate Change, which has developed more than 200 methodologies in the last 20 decades that can be applied. As I said, these come from a carbon market perspective, so very strict, but you could look at them and see it as rather as a guidance and following them. It's not a need to fully comply with, for example, all the reporting requirements. But beside the CDM, there are other standards like voluntary standards, the Verified Carbon Standard, VCS projects, which develop voluntary projects, but also following methodologies. Then there are other donor organizations out there that also provide guidance. For example, the Mitigation Action Facility, which is an international funder for large-scale projects, or the International Climate Initiative, EUKI, which also has some additional guidance documents. A good start, often as I would recommend, is though also to look into the CDM, the Greenhouse Gas Protocol, which also provides tools and methodologies. For example, one tool related to the causal chain, but then also on how to calculate this. If you have specific sector specific sector, there are also ready-to-use tools out there. For example, FAO has developed an ex-ante carbon balance tool, exact tool for the agriculture, forest, and land use sector. It's quite complex, but it gives some ideas on how to use it. And if you have, for example, a set of some changes in agricultural practice, then that could be used. Also institutions, international institutions like IGES, the Institution for Global Environmental Strategies in Japan, has developed Excel tools that are ready to use, applying some of the CDM methodologies. I have to say, and I forgot this maybe also under the CDM methodologies, some of them also provide ready-to-use Excel tools. Basically putting the underlying methodology already in Excel, and then you can use it. In most cases, I would say you should use that, and it probably needs an adaptation to your certain to your case. But yeah, there are tools out there that are ready and can help you. So a short example on the calculation, very simple case study. A PV system, so solar PV for hotels. The first step, as I said, impact assessment to identify the envisaged effects. We have a target group. We are looking at hotels and resorts in urban areas in our partner country. We, at the moment, we would like to, look at this more sustainable energy supply, so promoting the implementation of PV system because the sun is shining and we would like to use that. And we have two different project interventions. We have one which provides financial support. So in this case, 5 PV systems are directly financed to showcase at some resorts that it works. So with that, we replace the fossil fuel-based electricity, which is typically used and imported from the grid, national grid. And we can claim this as a direct mitigation potential. The second part is of our project, we provide technical support. We have capacity trainings for the hotels regarding finance, installation, maintenance of these systems. And with that knowledge and seeing that the systems, the pilot system works, the hotels and businesses decide to do the installation themselves. So they finance the system either with their own sources or from other sources. And in the end, also replace fossil fuel-based electricity. But since we are not taking the financial investments, we are not supporting this directly with our project, it's an indirect impact based on our technical support. For both, the calculation now would be the same, right? The direct and indirect mitigation in these cases, the number of PV systems we need to know, but the calculation on how much emission reduction can be achieved then is actually the same. So I now take only one case, in this case, the construction of the 5 PV system under the direct one, and how that could be quantified. I refer here to a CDM methodology, which is related to renewable electricity in captive use and mini-grids. There are others also where you have methodologies, for example, for projects that directly feed into the grid. But this one is suitable. You see the picture to the right, which comes from the CDM. We have a baseline scenario. In the baseline scenario, the electricity would have been supplied by one or more energy sources, either from the national grid or from a captive power plant. And as you see, in the baseline situation, the emission reduction related to electricity from the national grid would continue to prevail. In the project scenario, we construct 5 PV systems with an average 10 kilowatt peak, and they generate electricity which is then used directly by the hotels. So we replace the electricity used from the grid, and hence have an emission reduction effect. To calculate this, the baseline emissions, we need to know how much electricity we can generate with our PV systems, and give them a CO2 price tag. So that relates to an emission factor related to the displaced fuel or electricity. In our case, we said that in the baseline situation, the electricity would come from the grid. So we need to apply an emission factor related to the national grid. There are sources out there where you can find them. So what you need to know is actually the electricity generated by your and replaced by your project. In this case, as I said, for most renewable energies, but in particular for solar, the project emissions are zero, because we only look at those emissions related to the operation in most of the methodologies. That means no upstream or downstream emissions are considered. Obviously, if you like, and if you would like to do this, upstream and from the manufacturing can be included, but compared to the 20 years of operation, they are typically minor with solar, and about a couple of years, typically they are paid back. So, and it's quite complex to do that. So for simplification, typically we look only at the operation of these systems. So project emissions during operation is zero. In this case, for renewables and PV, also leakage, because we are not replacing any device that are used elsewhere. So energy efficiency measures this rather advise that we also need to look at what happens with the replaced systems. Are they operated somewhere else? That applies, for example, for energy efficiency, but also for vehicles, e-vehicles. If you buy new e-vehicles for a fleet of a public government fleet, for example, and then the old vehicles are sold on the market, then they're still existing, and you need to consider this. But for PV, solar, it's not. But this would also be shown, and guidance would be provided by the methodology that you apply. So in simple terms here, how is the math done? As I said, we have the total annual electricity generated by the PV system in red up there, and then we have the grid emission factor for the country. And if you split this up, how can we estimate if we don't have already the installation done and can measure the annual electricity? We can estimate it based on the number of PV systems times the average size of the PV system installed capacity times what we call the full load hours or capacity factor. And the capacity factor is showing how long in the year these systems are running at full time, at full capacity. And there are default values that you can use. For example, for solar PV, it's 16, but this is rather conservative. In many cases, in many countries, it really depends on obviously the solar irrigation and the location. It can be higher. So if you have better estimation, project-specific estimation, you can use them and do the estimation based on your local circumstances. The same applies to the grid emission factor, and I have linked here the source, the harmonized International Finance Institution framework on harmonized approaches, which provides default grid factors for almost all countries in the world, which are based on a CDM methodology, estimated on the CDM methodology, and are ready to use. So the link is in here. You will receive the presentation, and then for your countries, you can check it out, the value, and that could be applied for all energy-related, electricity-related projects, be it renewable energy generation or energy consumption or energy savings. So in the end, it's very simple. The overall mitigation in this case from these 5 systems is 34 tons per year. And we just need to know, okay, it's the emission reduction for 1 year that is running, and depending on your project, depending on when they are installed, for example, at the end of first year, then you need to multiply it for the remaining years to have the overall aggregated emission reduction, in this case, then for the remaining 3 to 4 years, 100 ton. That is obviously a very simple calculation, but it shows you hopefully the general approach that we have to look at the baseline emissions, the project emissions, potential leakage, and think about these 3 categories to determine the emission reduction. And as I said, if there is no specific project value already because you have specific data measured, then there are a lot of sources out there that you can use for the ex ante estimation. For example, with regards to the capacity factor or the potential solar irrigation at your place, the Global Solar Atlas, where you can put in the location and then you get the overall irrigation at your and the output also in terms of kilowatt hours per installed capacity. So that are helpful tools that you can use. They exist also for other technologies, like for wind farm, wind potential, but also for other parameters and default values. Sources exist. In particular, again, I refer to the CDM or the IPCC, the Intergovernmental Panel on Climate Change, which have a lot of material and default values to estimate in the conservative manner your overall impacts. So to wrap up and to summarize again, repeating a little bit of what I have said, how to report on your projects and how to understand what you are, what could be your impacts. Clear recommendation to build up an understanding of your project and related activities that leads to mitigation actions and identify the technologies that are underlying. To understand the characteristics, and to do that, ideally do an impact assessment. One tool, the causal chain, can help, but there might be others. It also, by the way, helps to identify other co-benefits, but also generally operationalize your project. I mean, you have to do anyway, set up a project plan, and it could be quite nicely be integrated early in the process. Then secondly, identify the emission sources and the potential emission reduction and do a quantification. Here, suitable methodologies are out there. I think the challenge is to know where to find it and which one is suitable, and then apply this. And then, yeah, clearly have a good understanding of the baseline and project scenario, because that lays the ground for the estimation. And then in the long term, for the implementation, also prepare a monitoring plan for an annual update of these resources, of these estimation. So with that, I would open the Q&A session, and hopefully, yeah, you got already a good basis understanding of the approach. We don't have too much time to go into all details at this stage, but yeah, the floor is yours, and I hand over to maybe Julia and Levin to see if we have some questions that came in the meantime.
Yes, I mean, before we get into the chat, I see one hand raised, so maybe we start with you, Simon, I think. Yeah, go ahead.
Yes. Do you hear me well?
Yeah,
Yes.
very well.
Yeah, thank you for a very nice webinar. It also helps me I'm preparing since 4 years application for EUKI initiative related to the supporting system for the farmers. In my project, I am promoting by the training production of the biochars for the natural fertilizers. I have a question because this webinar helps me also with picking up the methodology for the CO2 reduction. Should I show mostly in the project the direct impact on the reduction of the CO2? It is very simple in my case because 1 kilogram of the biochar is reducing roughly 3 kilograms of CO2 per square meter. So it will be very easy for me to estimate some minimal value during the project of the reduction of the CO2 by the farmers. Secondly, the indirect impact will be through the training, because during the training, I'm teaching my target group farmers how to use the biochars instead of the chemical fertilizers, and also how to use the renewable energy sources on the farms. So in the indirect system, I can also estimate some CO2 reduction. But the question is, should I show in the GHG calculations the, let's say, minimum plan and maximum plan? Can I estimate like a range of the values, or only so the minimum value, or only specific number, one number, or the let's say like the the bonduare between minimum and maximum values? That's my specific question.
Yeah, maybe I can answer, and then the colleagues Julia and Living can come in. Overall, if you have at the moment a little bit of uncertainty with regards to the overall impact, be it related to the hectares or be it related to the number of farmers, and that's why you come up with a range, I think it's fine, in particular at the early stage of your project. The further you probably are in the process of implementation and outlining your project, and you have more specific parameters with regards to your target group, be it, for example, the farmer that you are training, then the more precise you can get, I guess. And then the recommendation would be always to be conservative. So it's for the reporting, at least the ex ante estimation for the future, be rather conservative. And if you see then during the implementation, for example, you have reached more farmers, then you can report on this with a higher level. So the answer short, for the beginning, in particular, when we now look at the idea stage, where you would have a rough estimation, would like to argue about your contribution range is absolutely fine. And then in future, if you have more precise information, then it can be also one value, and that should be always a conservative one.
Yeah, thank you very much. The last question is, we are showing only the reduction of the CO2 during the project, or also like in the 3 years after we will close the project as well, like during the project, yeah, and then 3 years after.
At the moment,
only just at the end of the project. It is the most important for the evaluators.
At the moment, it's asked for the project or the emissions during the project duration. However, if you have, typically you do a calculation and there's a technical lifetime that goes beyond that, you could also present this, any impacts beyond the project duration, be it the years, a few years after your project, or even the technical lifetime. This obviously substantiates the overall impact that you have. But what is really important to report is the project duration, and anything beyond is it's important, it's good, but yeah, should be distinguished from each other. So not the overall emission reduction for the next 20 years only, you can provide this, but in particular also what can be achieved in during your project duration is important.
Thank you very much for the explanations. Of course, biochar stays very long time in the soil, hundreds of years.
Indeed,
So
indeed.
It's a long-term impact. Okay, thank you very much.
Sure.
All right. I think with that, the last point may be good to highlight again, because that already answers a lot of questions. It's the questions that I've seen a couple of times about the time frame, especially for indirect emissions reductions. And we've heard it's important to distinguish between what is achieved within the project duration and what is achieved beyond. And that's also important, I think, from an EUKI side, because you see, if you look at the application form, that it also highlights that you need to talk about what happens within the project timeframe. But as you've heard, indirect effects, of course, can occur outside, and it's just important to distinguish. And before we get to more of the EUKI side, maybe one more technical question for you, Stefan. I've seen some questions about the effect of carbon removals. First question would be, in case of a project that will preserve peat bogs, which store large amounts of CO2, will calculation of how much CO2 per year will be released from them if nothing is done enough? Or on the other hand, how much CO2 will remain locked if they are protected, and this be the result?
Yeah, thanks for that. Yeah, I have not touched base on this, but there's actually, I think also in the presentation, the reference to carbon stock enhancement. And carbon stock enhancement in particular relates to sequestration and preserve peat bogs, as you have mentioned in the example. Here, the approach for the estimation is a little bit different. So the estimation is the project emissions, baseline emission and leakage emission. The calculation is a little bit different because you're comparing exactly as you said. Okay, what either stays in the ground or what would be sequestrated. So you basically have to turn around the calculation. There are in the reference that I have put in here, in the CDM, for example, there are some reference methodologies as well to approach this calculation. I can recommend also to look at some of the publications of the International Climate Initiative, EUKI, which has last year published a whole guidelines and guidance document on agriculture, forest, and land use, in particular showing how the calculation works in there. And the important part here is always to think about the time frame. So when does the sequestration takes place and the permanence. So for how long can we secure that this stays in the ground, for example, or how that the forest is locked in. So that always depends a little bit on the situation, as I said, but there are methodologies out there. And in your case, you would estimate, okay, the baseline situation would be it is released, and if you avoid this, then this is your emission reduction. So again, very important, and that's why I highlighted that before. Define a realistic baseline scenario. What would happen without your project? And that is the reference case. And if you can argue that, for example, CO2, methane would be released, peat would be destroyed, then that is the case.
Thank you, Stefan. I'm going to hand over to Julia in a bit to explain more about the expectations by EUKI, especially for the first stage. But since you've already brought up the EUKI guidelines, Stefan, I was wondering if you were familiar with the guidelines from the National Climate Initiative, because multiple people seem to be familiar with that, and we're asking if you could recommend it.
I have not a complete overview of them, but what we can do is we check them and put them as a reference also in our material if we find them suitable for your cases. As I said, in general, there's a lot of material out there. In the presentation that we will send you, we have more slides with also more reference and direct links also to the International Climate Initiative. And yeah, we can include the National Climate Initiative documents of those that are useful and helpful. Yeah. But I will check afterwards and include them. Mm-hmm.
Thank you. Yeah, as Stefan mentioned, you will get all the material, and as we see, there's a lot of questions, and as we mentioned in the beginning, there will also be a little FAQ session, like a section in the documents that you will be sent around, and the presentation, of course, and also the recording. So we hope all the questions will be answered. But now maybe a big one that also covers a lot of what's been asked is EUKI specific. So Julia, the question is, what is expected to be presented in the first stage? Is it enough to show the potential impact on GHG reduction in a narrative way and to provide a description of the method to be used for calculation? Or is it already expected to provide concrete calculation in form of quantification or numbers?
Okay, thank you for this question. Actually, in the beginning, some of you might not have heard it if you joined a little later. I already said that basically in this first stage of the application, we do not, of course, need a fully developed emission reduction concept and not straight numbers. There was this question as well. There's also no given expected emission target values or whatsoever, or certain percentages that we want to see. So this was another question which came up. So actually it's for us the most important, especially for the indirect emission reduction, which accounts, I guess, for most of the project ideas you are handing in. It's really important that you think it through well and be transparent on the estimation and the projections that you are maybe taking, so that we can basically follow your thoughts and see, okay, you really thought it through, although they might be indirect, but what are you applying for the methods? It's important that you relate to them. So actually, as you wrote, it's for this first stage, for the indirect case, it's enough if you do it in a well done, how did you say it, written way, basically, with relation to target, to methodologies which you would use. And for the direct ones, of course, if you are already ready to estimate concrete emission reductions, then please, of course, go ahead. We appreciate if you can do so, that you relate to it accordingly.
All right, thank you, Julia. I hope with the previous answer, we've also, since we've hinted towards all of the guidelines that you will receive afterwards, covered the questions for more precise sources and guidelines focused on how to calculate emission reductions for education and development projects. As we mentioned, we will highlight that specifically afterwards, because of course we recognize and we see that there's quite some questions about that. Before I go to the chat again, I saw some hands raised before. If anybody wants to raise their question orally, you can do right now. Yeah, Radim, go ahead.
Hello, good afternoon. Radim Lang, Czech Republic. Our question is, our project is between the electromobility and community energy, connecting these two, and it basically, as I wrote in a chat, we really cannot calculate how much households can purchase the electromobiles in the next 5 to 10 years, or 3 to 5 years, because it's related economy and purchasing power. So it can go from 100 to 1,000. So why should we stick to it? So which numbers we should stick to?
I guess again that will, depending on the parameters that you have mentioned, that influence the overall impact of your project. A good estimating at the moment might be a range. If that would be possible, to show, okay, kind of optimistic scenario and maybe a lower pessimistic scenario with a minimum that you could achieve. I think you're right. In particular, ex ante estimation at the beginning of a project is always a challenge. But what we would like to see at this stage is potential contribution and how your project actually could contribute to that, and ideally even a way on how you have estimated that. But this number is not written in stone, and no one will use that at a later stage. You have promised more or less as before. If you show these kind of uncertainties and you show transparently some of your assumptions, because assumptions can always change, and that's the basis what we are doing here. We're doing a good guess, an educated guess based on estimations, based on assumptions. But if you put an assumption into an equation, then this should be plausible. But the assumption can change. So that's why it's so important to also be very transparent in your estimation at a later stage, when you, for example, do it in Excel and present an Excel tool, to say what is the source, what is the assumption based on, what is the justification for that. So in your specific case, I would recommend to highlight this uncertainty, to highlight also the external factors, but to come up with, let's say, as realistic as possible scenario and what you would like to achieve. And then you can still put a range saying, okay, depending on the uncertainties, it might be less or more.
Okay, and like name possible risks, correct?
Exactly.
All right. Thank you for the question. Thank you. Appreciate it.
All right. Thank you, everybody, for your attention so far. I see that we're already a little bit over time, and I've seen that some people also have to jump to their next meeting. So once again, I would highlight the fact that the recording will be sent around. We will send around all the guidelines, the material, and for now, we also have a little evaluation. Yeah, there you see it. We'll also send a link in the chat. Yeah, we would just appreciate some feedback on the event itself. But other than that, if you have very specific or important questions, once again, you can send us an email to info@euki.de. All the other questions that have not been answered yet, we will try to answer them in our FAQ. And for now, thank you for your attention.